Good morning. This is Altaf Hussain, former professor, Department of Chemistry, University of Dhaka. Well, I have been uploading a series of lecture on AS and A-level chemistry. This is the 28th lecture of the series, and specifically on organic chemistry. And we have been talking on organic reactions, reaction mechanism, etc. Now, type of organic reaction and organic reaction mechanism we will be talking a little bit. Organic reactions, by summarizing the overall reaction in series of steps, is called reaction mechanism. All chemical reaction, whatever organic or inorganic, involves breaking and making chemical bonds. We know in our earlier lectures that many organic compounds do belong and do have covalent bonds. And we will see how these covalent bonds can be broken and can also be formed. So there are two types of fission by which we break the bond, covalent bonding: homolytic and heterolytic fission. Let us talk about homolytic fission. We know, let's say this is not an organic compound, this is hydrochloric acid, and we know that in hydrochloric acid, hydrogen and chlorine have covalent bond, and this bond form, as we talked earlier, one electron of hydrogen and one electron of chlorine share together, and that form the sharing of bond, and we call it covalent bond. Now, if we just break this bond and have the one unpaired electron on hydrogen and also an unpaired electron on chlorine, and then this is called homolytic fission, and thereby we get free radical, hydrogen free radical and chlorine free radical, and these free radicals are very active. What is homolytic fission then? Homolytic fission, again, uneven breaking of covalent bond. What is the, again we see here this, we know that in hydrochloric acid it's a polar bond. That means chlorine is highly electronegative atom compared to hydrogen, and therefore sharing of this bonding electron, chlorine pulls this bonding electron towards itself, and that's why we say that chlorine is highly electronegative, and therefore it's a polarized bond. And when we break it, it can be this, that we can have this chloride ion and hydrogen ion. The breaking is like this, that we get a hydrogen ion and a chloride ion. We can have also such sort of breaking, that is hydrolytic fission, in organic compounds. So let's say we have methyl bromide, and that bromine is highly electronegative atom. Therefore, the bonding pair of electron comes towards bromine, and thereby we get a methyl ion and bromide ion. And these what we will use for explaining the reaction mechanism in organic compounds or organic bonding. So there are three types of, well, we go back to the earlier side, that what we call carbon cation, this one, carbon cations. And this carbon cations, carbocations, there are three types of carbocations: primary, secondary, and tertiary carbocations. Which one is primary? If we have an alkyl group, attached to this carbon atom, then we call it one alkyl group, we call it primary carbocation. And then if we attach two alkyl group like this in this cation of carbon cation, and then we get secondary carbocation, and then we have tertiary carbocation, three alkyl groups attached to this carbon atom, tertiary carbon atom. And that what is alkyl group is CH3 or C2H5, C3H7, etc. Many alkyl group we do have. So from there, we also know that the primary carbocation is less stable and stability increases, and the most stable is tertiary carbocation. Okay, now these carbocations are an example of species called electrophiles. What is electrophile? An electrophile accepts a pair of electrons, and this results a formation of new covalent bond. Similarly, we have nucleophiles. What is nucleophiles? Nucleophiles are electron-rich species. Electrophile is electron-deficient species. Nucleophile is electron-rich species. So a negative ion like this or a charge like this, we call it nucleophile, which can donate a pair of electrons. This donation can also form new covalent bond. Okay, then types of organic reaction. What are the types of organic reaction? We know all organic molecules can be burnt out, and this burning process, we will see that it's a redox reaction. And that's redox reactions, the reaction depends on the structure of molecules. Molecules having double bond are said to be unsaturated molecules. That is a carbon-carbon double bond, which is unsaturated molecules, you see. So molecule having double bond with carbon atoms, I will call it unsaturated molecules, and we can another molecule add on it, and we call it addition reactions. Saturated molecule, this is an example of a saturated molecules. Saturated molecules which have a single bonds, then it can react in two possible ways. One we call substitution reactions, another elimination reactions. So both saturated and unsaturated molecules undergo hydrolysis reaction, which may involve substitution or addition steps. All types of unsaturated molecule can be saturated by reacting with hydrogen in presence of a catalyst. All types of unsaturated molecules. Here you see this is an unsaturated molecules, and we are reacting this with hydrogen and with a nickel catalyst and get this saturated hydrocarbon, and that is an example of addition reaction. I should say here that the types of reactions we will discuss. This is what is a preliminary idea of types of reactions we can have in organic molecules, but we will definitely get examples of these reactions in various steps while we are lecturing on homologous series of organic molecules, functional groups of specific functional groups of organic molecules. Let's first say when we will be on alcohol or acid, organic alcohol or organic acid, or homologous series like alkenes. We will see that there are many different types of reactions. These different types of reactions are coming up while we study in individual group of compounds. So now we are talking about let's say we talk about reactions of alkanes. We know that alkanes are a group of compounds, homologous compounds, and we do have also the general formula of alkanes. And alkanes in general are unreactive compounds. Why? That's carbon and hydrogen have got very little electronegativity difference, so they are not polar, and so they are not attacked by nucleophiles or electrophiles. They have, because they have no positive charge like this. So, however, alkanes do react with oxygen, that is combustion reaction. When we burn alkane, we call it combustion reactions, and undergo substitution by halogen in sunlight. We get combustion reactions and also substitution reactions in alkane. So let's talk about combustion reaction. If we have a complete combustion of alkane, then what will be the result? This is the reaction of it. This is an alkane, and we are completely burning it with oxygen, and then we get carbon dioxide and water. Therefore, if we talk it like this, all hydrocarbons here are completely burned, and that is an example of complete combustion. Unfortunately, we do get also when we get combustion of, say, petrol or diesels in a car engine, we do get a limited supply of oxygen there when we ignite, and therefore we get incomplete combustion. And the incomplete combustion, this what it is. We do get the product becomes carbon monoxide and water instead of carbon dioxide and water for complete combustion. Therefore, when you get carbon monoxide, it's a toxic gas, and we do not want this toxic gas. And this is the reason why we have to take care of, so that we do not get incomplete combustion in a car engine, and thereby we use catalytic converter so that least possible carbon monoxide gas we gas through exhaust. And it's a toxic gas, and if a person is poisoned with carbon monoxide gas and immediately not transferred to medical hospital, the victim may die even. Reaction of alkanes with halogen. Alkanes with halogen. Here this is an alkane we call methane, and chlorine as symbolic here. It will not react unless we have sunlight. We do not get any reaction of chlorine and methane in dark. So we need sunlight, and there we get methyl chloride compound and hydrochloric acid gas. We can talk a little bit of reaction mechanism of this compound, how it happens. Well, we say that they will not react in dark, but they do react if we get enough energy to break the bond, and this energy can be given from ultraviolet light, that is from sunlight. And so if we keep it in sunlight, the energy absorbed by a photon of 400 kilojoules per mole. And if we have chlorine like this, then we have homolytic fission, we need 242 kilojoules per mole. So we get free chlorine radical, and then this free radical and then methane, we can also have homolytic fission of methane and get methyl radical and hydrogen radical. So here it's this. So if we look to this electrolytic fission of either chlorine or methane, we see that we need much higher energy. So what happens when we start with chlorine, first chlorine with homolytic fission, we get this free radical, and this free radical is the initiation of the reaction between methane and chlorine, initiation of the reaction. And this needs 242 kilojoules per mole. So this free chlorine radicals react with methane and gets hydrogen chloride plus methyl radical. And you see this. And this methyl free radical now reacts with chlorine atoms to form chloromethane and generate another chlorine free radical, and new free radical reacts again with methane and thereby reacting with other hydrogen atoms and forming compounds. And these repeated action, we call that the second stage, and that second stage is the propagation stage of mechanism, propagation stage. Now we need to know what happens then. Propagation ends only when we do not have any free radical in our reaction mixtures. And we do not have any, if we do not have the free radical in our reaction mixtures, that is the termination stage. And how there are many different ways of termination stage, and this is exothermic reactions. And we see that other one was endothermic reaction, but this is an exothermic reaction. So here we see that two chlorine radical mixed together form chlorine molecules. Similarly, methyl radical and free chlorine radical form methyl chloride. Also, two methyl radical form ethane. So this is how we see the termination stage. Now, if we look to this picture, what we are talking about here, that if we do not have light, so we do not have light here, no light, then we can see the mixture of bromine and hexane. Just it doesn't react. But with sign light, if we have this 0 second, but then after 10 seconds we get the mixture, and then after 16 seconds we see that we have hexane and bromine reacts, and we get bromohexane after 16 seconds. Okay, then types of organic reactions I have been talking about, and you see we said addition reactions, and we showed an example of halogen alkane reacts with bromine. We get an addition reactions. What about elimination reactions? Well, addition reactions, eliminations. What we remove a small molecule from the reactant, and how it works. That let's say methyl alcohol, when in concentrated sulfuric acid, we get ethane, is it not? Ethane, and then water molecule. We get out water molecule from here. So condensation reaction, a two-step reaction where addition takes place, and this is followed by second step, which is called elimination, and that what we call condensation reactions. We come with final product occurs, and we come with examples later, and then substitution reactions. We had given an example of substitution reactions in earlier when methane and chlorine reacts and its reaction mechanism. We showed too. Okay, so hydrolysis reaction. That we said that both hydrolysis breakdown of molecule by water. If we put water in as the reactant, we can break down it, and that's also called a hydrolysis. So, for example, hydrolysis of halogen alkane. This is halogen alkane, and putting water in it, we get alcohol plus hydrogen bromide. This hydrolysis became faster. You see, faster when if we use some acid or alkali, then it becomes faster. So, for example, here we have halogen alkane plus alkali. We get alcohol plus sodium bromide. And we did talk about oxidation and reduction reaction, that is redox reaction, which also occur in organic chemical reactions. So oxidation means loss of electrons from a basis. And we did talk about oxidation reaction, reduction reaction, and in earlier inorganic chemistry, details about oxidation reduction reaction, but loss of electrons. So if we have alcohol, generally we show like this, and oxidation is going on. And then what sort of media it is, what is the reagent we are talking, we show it here like this. And then we can, that is methyl alcohol when oxidized in presence of dichromate, acidified dichromate solution, potassium dichromate solution, we got methyl aldehyde and water. This is all. So before the reaction, ethanol contains 1 oxygen atoms and 6 hydrogen atoms. After the reaction, ethanol contains 1 oxygen atoms and 4 hydrogen atoms. In fact, ethanol loses 2 hydrogen atoms. So we say that the ethanol has been oxidized. Similarly, notice that 1 oxygen here, and in the next slide we show it's 2 oxygen here. Just to see the number of atoms in the left hand side, number of atoms in the right hand side, we showed a harsher condition of oxidation, and thereby we denote it by 2, and that part is oxidation, hard oxidation, strong oxidation. So oxygen represents for the oxidizing agent, and 2 in front of it is needed to balance the equation for oxygen atoms, is it not? Reduction is defined as the gain of electrons. Let's talk about what is it? Acetic acid or ketone. It's a ketone, and we reduce ketone using what we use as reducing agent, that is sodium borohydride, and symbolized by this hydrogen, constant of hydrogen, right? And then what we do get, that it's an alcohol. Let's say it's an alcohol. We name it later. It's an alcohol. Notice that this, again, we use H here to simplify the chemical equation describing reduction reactions, and H represents the reducing hydrogen atom for the reducing agent, and 2 in front of it is for the balancing of the reaction. That's what it is about. The main reactions, organic reactions, what we do see in different chapter of organic chemistry. As I said, it could be alkane, it could be alkene, or even some functional group organic chemistry, for example, aldehyde, acid, ketone, etc. We'll talk about this when we come to this again in chapter wise. Hope to have the next lecture for only for alkane and alkenes, reactions of alkane and alkenes in details. Thank you very much for your patience hearing. Thank you.